question. Well, when I was a kid, I loved science experiments. These days, local students have certainly upped their game from when I was in school. Carolina Impact's Jason Terzes introduces us to students sending their microlab to the International Space Station.
3, 2, 1. Mission sequence start and liftoff of the SpaceX Falcon 9 rocket.
Imagine the excitement of watching a rocket take off, knowing what's on board contains something you spent countless hours working on, only to witness minutes later something go horribly wrong.
And we appear to have had a launch vehicle failure.
From sheer excitement to utter disappointment, students at Carmel Christian School in South Charlotte have experienced it all.
My first reaction was shock.
It was devastating.
We saw all of that hard work, all those hours, all that time after school just go up in flames.
The students are part of the school's STEM team, science, technology, engineering, and mathematics. Starting last school year, the school partnered with the Quest Institute for Quality Education and NanoRacks, which conducts research on board the International Space Station.
I never thought about space and the great beyond, but when this program came up at our school as an opportunity, I jumped on it the minute I heard about it because it's so different than any other science class that we've ever had at Carmel.
For their first project last year, the team wanted to test magnetic ferrofluid, a fluid that has magnetic properties, and how it would be affected by microgravity in space. If that doesn't sound complex enough, the students had to build all the necessary components to conduct their experiment, and all from scratch.
So they have to design the mechanical components to be able to run on their own. They have to write the computer coding in order to run the program. They have to use the design their own electrical board and actually do the electrical soldering with all of the circuitry that's necessary to run the experiment.
Measuring just 3 inches high, 2 inches wide, and 2 inches deep, the students shipped their microlab to the Kennedy Space Center to be put on a rocket with other experiments. Several team members drove to Florida to watch the launch.
The friend that went with me, her mom said that the rocket exploded, and we're like, no, it didn't. No, we saw it go up, and everybody was cheering, and everybody was really excited about it. And then Mission Control said the launch vehicle has failed. And that's when we knew that it actually exploded.
I was watching it on TV, and we had put all this time into it, and we got it on the rocket, and we felt like, okay, we've done our job, it's going. And to see it go up, and all of a sudden, it's just gone.
I was absolutely devastated, more for the sake of these kids, because these kids are so passionate about this program and what they do. They pour their heart and soul into it. They stay after school, they come early, they give up their Saturdays to make sure to meet all of these deadlines, and then to see everything that you've worked so hard for and for the past 9 months explode literally before your eyes. It was really devastating.
The rocket's explosion taught students some valuable lessons: how to deal with failure, overcome adversity, how to regroup, and ultimately rebuild.
It's hard to really want to come back and do it again and put it on another rocket knowing the same thing could happen. But we just had to persevere and know that the research we had put into it and all the design challenges that we had overcome weren't wasted.
Liftoff.
After months rebuilding the experiment, the students were thrilled that December's relaunch was successful.
And then sometimes I step back and I'm like, wow, I'm in high school. I'm only like 17 years old, and I'm sending something to space.
For 30 days, a micro camera took pictures, transmitting them through NASA and back to the class. More data will be collected and analyzed once it's back.
We have very limited knowledge of, is everything working other than getting our picture back? Are all of our mechanical pieces still functioning? And so once we get that back, check out the fluid, make sure everything is good, then we can finalize our data analysis and draw our conclusion to see whether or not that microgravity did change the effects of the magnetic fluid.
While waiting on the results of their first experiment, the research team continues working on their next outer space endeavor, testing for bioluminescence, which is the production and emission of light by a living organism. Translation: it's a glow-in-the-dark mushroom.
So we wanted to do something along the lines of like decomposition or plant growth, and then we thought of mushrooms, and we're like, yeah, let's do that. But we needed this wow factor.
We wanted to do something biological, which adds a whole nother set of challenges with keeping something alive in space and keeping something alive in transit.
So we did a little more research and we found that there were these bioluminescent mushrooms called Pinellus dipticus, and we totally fell in love with them.
Among the challenges, finding what kind of mushroom will grow in space, what to grow it on, and how to water it, all while leaving enough room for everything else that needs to go in.
We have to put our board in there, we have to put a camera in there, the growth chamber, the growing mushrooms, the pump, the tubing to the whole irrigation system all fits in less than the size of a Coke can.
While the research team receives some outside help on their projects, such as computer coding, for the most part, if there's a skill that's lacking, the students take it upon themselves to figure out what to do. They'll all be watching as the experiment launches this spring. For Carolina Impact, I'm Jason Terzis reporting.
Thanks so much, Jason. This program has encouraged some of the Carmel Christian School students from the STEM team to pursue careers in engineering. Remember, we're always looking for great stories about students across our region. So if you have an idea, please send us yours to carolinaImpact@wtvi.org.